Okay, so today we're going to be looking at Module 2.1, and this is B, so this is the second part of what we started before, and we're still dealing with modeling with expressions. So we're just kind of taking it one step further with what we were doing yesterday and talking about our expressions a little bit more in detail. So when we look at what our statement is for today, what we're going to do is we're going to use keywords and verbal cues to create expressions with coefficients and terms. So before, what we were doing is we were just identifying the different parts, but now we're going to take verbal cues to create expressions of our own so that we can use them to create expressions. So if you look at the list of words that we have here, these are known as trigger words, or these are the verbal cues that we'll be using to tell us which operation to perform. So when we first look at addition, obviously the key word for addition that we're going to be looking for is kind of the operator word sum. Anytime that it's asking you to sum, that means to add things together. So if you look at some of these things here, you have the sum of, added to, plus, more than, increased, total, all together, and the word and. Those are all some of, and not necessarily all of them, but those are words to look for that would mean that we're going to be adding two different things together. Now, in a similar fashion, we can say that subtraction has verbal cues or trigger words less than, minus, subtracted from, the difference of. So the big word that we will be using for subtraction is anytime that you see the word difference. Difference means subtraction. It's telling you how are these two things different. You do that with subtraction. Take away from, reduce by. So we're always looking for these words that mean subtraction. Now, multiplication and division are going to be working a little bit differently. Now, remember, these are going to be related to what we call factors. Now, factors we talked about last time were pieces of multiplication, and one way that you can start to understand things is that division is just another way that you multiply, but just multiply a little bit differently. So when we're looking for multiplication and division, couple of the things that we're looking for are factors, and if you remember some of the words that we were using before, factors are also something that we know as being coefficients. So anytime that you see multiplication and division, this is going to be changing or creating something that we know as coefficients or factors, and then where addition and subtraction, remember, terms are separated by addition and subtraction. So when we look at these trigger words, this is what we're looking for. We're looking for addition and subtraction to identify terms, and we're looking for multiplication and division to show factors or to show changes in these terms. So if we keep going on with multiplication, the big word for multiplication is product. So product is multiplication. You have times multiplied by, the product of, percent of, and sometimes the word per will also do that, and we'll talk about a couple of examples of that. Division, there's not really a whole lot, but the big word for division is quotient. But if you notice that it's divided or a ratio, that's something that we've talked about before too as well. Or two, what we could look at, division is also fraction. So anytime that you talk about something being split into groups, fractions or groups. So anytime that you see groups or fractions or pieces, that usually leads you towards division. So you might want to go through those and keep this handy because we will be using this throughout today's lesson. So first of all, just like I had kind of mentioned before, we want to be able to understand expressions first before we start building our own. Now, the last video left off a question that was very similar to this, asking you what do these different pieces represent. So what we're going to do is we're going to kind of pull this apart and kind of look at this. So if we read this, Lorenzo buys 3 shirts at $S a piece and 2 pairs of pants at P dollars a pair. And so we want to know, what does this expression represent? Now, first of all, we can look at it in terms of terms. So we have 3S plus 2P. So we're adding things up together, so we know that at some point we are looking for some kind of total amount. Now, you're buying something, so this whole expression is going to represent kind of a total cost, if you will. Now, when we break this down individually, you have 3 times s, and this here at this level, remember we're identifying factors. So whenever we identify terms, we then break those down and identify the factors. Now when we look at this, he's buying 3 shirts, so this is just the number that he's purchasing, so it's a static constant 3, where this individual piece, the variable this time, is actually referring to the price. So this means that the price can be something that is going to be changing. So it doesn't necessarily have to be the price being the coefficient, but recognizing what is the thing that can change, what is the thing that stays the same. Now in a similar fashion with this other one, we have 2 and we have p. So if those are our 2 different factors that we have. 2 is going to represent the number of pants that he is buying, where p is going to be, again in this case, the price of pants. So in a similar situation, the idea is that we have to understand what the coefficients are, we have to understand what the variables are representing, because they don't always have to represent the same thing all the time. So in this case, 3s represents the number of shirts, or the cost of shirts that he is going to purchase, and the 2p is going to represent the total cost of 2 pairs of pants. So just understanding how we can break those apart and understanding the different pieces. Alright, let's look at one more example of just kind of breaking these apart. If a car travels at a speed of 25 miles per hour for t hours, then travels 45 miles an hour for m hours, what does the total expression, or what does the expression 25t plus 45m represent? So again, let's break this apart into 2 different pieces. We have 25t plus 45m. Now, when we kind of look at this, it might be a little confusing at first to kind of see this. So we have a rate. This is what this is called. This is a rate, and that's 25 miles per hour. And then we're going to be driving for t hours. What that ends up telling you is that this is going to tell you a distance that he's going to travel. So if I tell you that I have a certain speed, and then I tell you how much time I spend, that means that it's going to end up giving me a distance, and that's something that you talk about in a science class or kind of in a physics type of class. But here, 25 represents, in this particular case, so we have 25 and we have t as our 2 different factors. 25 in itself represents the speed, and t represents the amount of time. So we're kind of breaking that apart and realizing what these things represent. But again, this represents the total distance traveled at that speed. We break apart 45m, the same thing happens. We get a speed of 45. That's how fast I traveled. That's the thing that's remaining constant. That's not the thing that's changing. I'm telling you that my constant speed is going to be 45. What changes, though, is how much time I'm going to spend driving at that speed, and that's going to be represented by the other variable, m. So notice that we're using 2 different variables to talk about 2 different speeds and 2 different times that I'm traveling. So that's how we create these expressions. That's how we use these to our advantage. So just understanding how these things put together. Now, one of the things that I want to mention to you before we move on to the next part is that coefficients are constant. So if you notice about all of these coefficients, the 25, the 45, those are representative of the coefficients, and that's something that we talked about in our last video. 25 and 45 are constant. Those never change. But the other idea, the variables, and this is something that we should already kind of know for that, but I'm just going to write that down here. Variables are the things that are either unknown, so we don't know how much time that we're traveling for, or it's something that can change. Now, most of the time we think of variables as changing, but it's just something that we don't know. It's just a placeholder waiting for me to tell you, okay, how far or how long am I going to be driving at 25 miles an hour, and then how long am I going to be driving for 45. So it's just something that's unknown or something that does change. Okay, so now we're going to use verbal cues to write expressions. So take a look back at that that trigger word list and kind of look at some of the things that we're looking for. So the first thing that we're going to be looking for to kind of set up is terms. So we want to find different number of terms. We want to think about how many things are being added or subtracted together first. So don't necessarily worry about what's going on. Now, as far as setting up a specific expression, the first thing that we want to do is we kind of want to write a simple sentence. So the idea in order to be able to create these is we want to write a simple sentence just explaining what the situation is. So what we want to do is we want to write an expression to model this scenario. So we're going to look at our scenario here. And then that's what we're going to do. We're going to write kind of our simple sentence. So the price of a sandwich is $1.50 more than the price of a smoothie, which is $D. So the idea is that our expression needs to model the price of a sandwich. Now the price of the sandwich is not $1.50. The price of the sandwich is $1.50 more than the price of a smoothie, which we know is $D. So I'm going to write this just kind of in simple terms. 150 more than a smoothie. And so this is an example of a simple sentence. Notice that there's not very many words here. I took basically that entire sentence and reduced it down to just 4 words. 150 more than smoothie. And so the second step that we're going to do is we're going to show operations. So we want to look at our operations. We want to look at those. We want to look at those trigger words, and the word that should pop out at you is more than. And so when I break this apart and I write my next line, this is 150 plus the smoothie. Now notice that I kept the same word there because this is something that we don't know. The smoothie is the unknown here. And so my third step in order to kind of write expressions is to find the variables and replace them. Now we are told what variable to use, but if we're not, you can use whatever you want to. So we're told that a smoothie is $D. And so we're going to find the variable and then we're going to replace it. And so this will bring us to our final piece of our expression where it's 150 plus D. And so this expression right here represents what the cost of a sandwich is or what the price of a sandwich is. So if I know the price of the smoothie, then that will tell me what the price of the sandwich is. Now obviously that cost could change, so maybe the size of the sandwich or the type of the sandwich will change based on, let's say, the size or the flavor of your smoothie. So that's just how this particular scenario works out. But if you notice, we follow these three simple steps. We wrote a simple sentence, $1.50 more than a smoothie. We showed the operation that was being performed, and so in this particular case, it was addition. And then we found the variable, which was the smoothie, and we replaced it with an actual letter to complete our expression. Alright, so our last example is that Erin is buying produce at the store. She buys C cucumbers at 99 cents each and A apples at 79 cents each. We want to write an expression to model this scenario. So again, first step is that we want to write a simplified statement. So we're going to write a simple sentence. And so the first thing is that Erin, we'll just say buys, I'll put this in the right order here, buys cucumbers and apples. Now most of you would probably agree with that statement that she's going to the store and she's buying cucumbers and she's buying apples. Now the first thing that we have to do is that we have to understand that cucumbers come at a cost and apples come at a cost. And this is where this multiplier that we were talking about, coefficients were multipliers. Factors are multipliers. So we're taking these cucumbers and we're putting a value to them or a constant to them, which is typically going to be your coefficients. And so these are a little bit more complex, so we're going to find the operations. So first of all, we're going to have, I'll just write cukes, and remember and is addition, so we have cucumbers and apples. Now, it's not just how many that she's getting. We want to say what amount is she spending at the store. So how much does this stuff cost? And so the idea is that we can replace cucumbers. So if we look at our third step is to look at the variables and replace them. So cucumbers, we're going to say C. Apples, we're going to say A. And that's what it told us in our statement here. Now, the fourth thing that we didn't necessarily go over in the last one because it wasn't a big deal is that we want to look for coefficients. Do these variables have a multiplier? Do these variables have some kind of constant that would go along with them? Well, in this case, they particularly do. So cucumbers are 99 cents each, and apples are 79 cents each. So the way that we do this is we use our statement that we currently have, C plus A, and if we add a little bit to this, and we say 0.99 times C, what that's going to tell us is similar to those other examples that we looked, that's the total cost of any number of cucumbers that you want. And then over here, if I say 0.79 times A and use that as my coefficient, now that's going to tell me the total cost of apples, where the number of cucumbers and the number of apples, those are the variables, but the prices are what's constant. So the idea is looking at these examples and kind of piecing these things together using our operations, our variables, and our coefficients. And if you look, this is exactly what we did in these 4 simple steps. We wrote a simple sentence. We did operations. We looked at the variables, and then we added in or multiplied in factors and coefficients to kind of change the expression into what it's supposed to be. So that's going to do it for this video, and we'll look at these when we come back to class.